Generally, calculation of quantities such as charge density by quantum espresso belongs to post-processing, or in abbreviation PP calculation. Indeed, the purpose of pp.x is data analysis and plotting. It reads the output produced by pw.x, for example, self-consistent field calculation, and then extracts and calculates the desired quantities. To do charge density calculation for graphene, I create a folder with charge name, and I put the contents of self-consistent field folder in it. Then we should create an input file for post-processing calculation. I use PWGUI graphical interface. I select file, new, new pp.x input. We should specify the prefix name. Note that the name we give here must be the same as the name we specified for self-consistent field calculation before. Then we give the path of the folder we created for the charge here. In this section, I mean plot underline num, we define which quantity we want to extract. For example, we can choose charge density, or total potential, or spin polarization, or wave function. I choose here charge density. Then we go to specify plot section. N file defines the number of data files to read. Its default value is 1. Then we should specify the name of output file. For example, graphene underline charge underline cube. Then we should define the iflag parameter. This parameter defines the dimensionality of plot. If it is equal to 1, it means we have a one-dimensional plot. If it equals 2, it means we have a two-dimensional plot. I choose three-dimensional plot, and thus in the input file iflag becomes equal 3. Then we should specify the format of output file. Output format depends on the approach that we want to plot the extracted file. Can use XChristin, GNUplot. One of the popular formats is for Gaussian cube file that can be read by many programs. We will describe this format after the creation of this file for density. Note that the quantity values are saved in this file. Then we should save this input file. In the charge folder, the name is gr.pp.in. We can see this input file here. It is the content of post-processing input file. Now we should run the post-processing. To do this, we go to the terminal environment. In the terminal environment, we write pp.x, the name of input file, gr.pp.in, and the name of output file. After a few seconds, you can see that this file, graphene_charge.cube, is created. There are many programs that we can use to see this charge density file, for example, Xkristine. One of the best programs is Vesta. We can download it from this site. We go to this site. In the download section, it has a different version for different system. We should download this for Linux system. File is downloaded. Now we should unzip and extract this file. By clicking on Vesta, the program runs. Now we can open our file here. This file graphene underline charge.cube. You can see the charge density of graphene here, charge density in the unit cell. Charge density in the unit cell of graphene. Also, we can see the wave functions in graphene lattice. To see this, like charge analysis, we create a wave folder, put self-consistent field contents in it. In the input file, we change the directory. Also, we choose this psi to the power of 2. In this case, we should specify the k point and band of the wave function. For example, the first k point and band between 1 and 6. We save this program. See the input file here. Now we open the terminal environment. And run pp.x with this command. We can see this wave function with Vesta. For example, I open one of the wave functions. I want to speak about the cube format. This format originates from the Gaussian software. The first two lines are comments that are ignored. The third line has the number of atoms and the position of origin. The next three lines give the number of voxels along each axis followed by the axis vector. The last section in the header is one line for each atom, consisting of 5 numbers. The first is the atom number, the second is the charge, and the last three are the x, y, z coordinates of the atom center. In the following, the quantities values, in our case charge density, are provided in 6 columns. This is the format for cube.